Good afternoon, my Algebra 1 peeps. It's time for another lesson. It's time for Lesson 1, Solution Sets for Equations and Inequalities. Bum, 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 ba-da-da-da-da-da. Bum, 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 ba-da-da-da-da-da. All right. So we are talking about solution sets for equations and inequalities. So look at example 1. Consider the equation x squared equals 3x plus 4, where x represents a real number. Okay. Are the expressions x squared and 3x plus 4 algebraically equivalent? Okay. In other words, can we guarantee that whatever value we substitute in for x will always be equal to each other? Okay. Can we guarantee that? No, we can't. So in this case here, these two are not. So no, okay, niet, all right, all right, none, all right, not happening. These algebraic expressions are not equivalent to each other, all right. Now, we can sit here and prove this by looking at the following table. The following table shows how we might sift through various values to assign to the variable x in the hunt for values that would make the equation true. Okay. Now, if for something to be algebraic equivalent, it has to be true for every number we place into it. Okay. So let's start off with 0. Okay. We say 0 squared is 0 equals 3 times 0, which is 0, plus 4. So does 0 equal 4? No, it does not. Okay. What if x equals 5? 5 squared is 25. 3 times 5 is 15. 15 plus 4 is 19. 25 does not equal 19. But look down here at the very bottom. 4. 4 squared is 16. 3 times 4 is 12. 12 plus 4 is 16. 16 does equal 16. 4 is the only value that would make that statement true. Okay? And that's what we have to figure out. We must find out what values would make an equation like that true. All right, so let's continue on. Okay, so consider the equation 7 plus p equals 12. Okay, going to make this really nice and big for us. All right, so now we have an equation, and we must determine whether or not any value that we substitute in for p is going to determine whether or not this the statement is true. Okay, so we start off with 7 plus p equals 4. So we're going to say let p equal 4. So 7 plus 4 equals 12. Does 7 plus 4 equal 12? It does not. So this is a false statement. Okay. What if we let p equal 1 plus the square root of 2? 7 plus 1 plus the square root of 2 equals 12. Well, 7 plus 1 is 8. The square root of 2 is like 1 point something other. 8 plus 1 point other is like 9 point something other, and that's not going to be 12. So that's a false statement. All right. What if p equals 1 divided by pi? 7 plus 1 divided by pi equals 12. Well, pi is 3.14. 1 divided by 3.14 is still going to be approximately 1/3. So 7 plus 1/3 equals 12? No, that's a false statement. Okay, so this is false. What about let's p equal 5? 7 plus 5 equals 12. Is this a true statement? Yes, this is true. All right, 7 plus 5 does equal 12. Okay. The solution set of an equation written with only one variable is the set of all values one can assign to that variable to make the equation a true statement. Any one of those values is said to be a solution to the equation. All right, listen to that again. The solution set of an equation written with only one variable is the set of all values one can assign to that variable to make the equation a true statement. So we're looking for all the values that we can substitute in for p that would make the algebraic equation true. That would be the solution set. All right. Now, to solve an equation means to find the solution set for the equation. Now, I love problems like example 3. Well, hold on. Let's do this the old-fashioned way since it's going to be picky on me here. All right, that's close enough. Let's come down. Whoop, too far. I brought that down too far. Come on. All right, there we go. So let's solve a squared equals 25. Okay. You've worked with solving equations before. So we are trying to solve for a. What value of a can equal 25? Okay. Now, this is a very interesting solution. Okay. Because we have a squared equals 25. Now, we know that to undo a square, we have to use a square root. To undo a square, we use a square root. So a squared equals 25. Now we do the square root of both of these. Okay? Now here's the interesting part. Okay? When you do a square root, you have to do this. A squared equals the plus or minus of the square root of 25. I'll explain why in just a minute, okay? So the square root of a squared is going to be a equals the plus or minus the square root of 25, which is 5. There are two solutions to this equation. The reason we do the plus or minus is because when you are working with a square, there are two very well-known values that can suffice to give you 25. That is a positive 5 and a negative 5. Think about it. Let me substitute in and show you. 5 squared equals 25. That's true. A negative 5 squared equals 25. Can that be true? Negative 5 times a negative 5 is a positive 25. That is a true statement. So when you're working with squares, you have to make sure that you put the plus or minus when trying to solve. Because there could be two values that could suffice for the solution. But in order to verify, we still have to sit there and check like we did. We put in 5 and a negative 5 to verify the solutions were true. So A does equal positive and negative 5. Okay? Interesting. So here you go. This is actually a wonderful spot right here. Okay? And it shows you how to write it in set notation and everything else. Okay? So one can describe a solution set in any of the following ways. In words, a squared equals 25 has the solutions of 5 and a negative 5, because a squared equals 25 is true when a equals 5 or a equals a negative 5. You can write it in set notation. The solution set of a squared equals 25 is the square, negative 5 and 5. And you notice they put it in brackets. The brackets are what we use to indicate a set. Okay? Then you can use a graphical representation on number line. The solution set of a squared equals 25 can be located at negative 5 and 5 on a number line. Now, in this graphical representation, a solid dot is used to indicate a point on the number line that it is to be included in the solution set. Warning, the dot one physically draws is larger than the point it represents. One hopes that it is clear from the context of the diagram which point each dot does refer to. All right? Now, you notice how they set there the set notation. Curly brackets indicate we are denoting a set. A set is essentially a collection of things, letters, numbers, cars, people. In this case, the things are numbers. Okay? From this example, the numbers negative 5 and 5 are called the elements of the set. No other elements belong in this particular set because no other numbers makes the equation a squared equals 25 true. So when elements are listed, they are always listed in increasing order. Negative 5 to 5. Negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. Increasing order. Sometimes a set is empty. It has no elements, in which case the set looks exactly like that, just double brackets. We also denote this with the symbol 0 with a line through it. We refer to this as an empty set or the null set. All this is important. Okay, I'm telling you, every ounce of this is important. Please make sure you highlight, denote, circle, whatever you have to do. I want you to remember all this stuff is important. All right? Remember it. Know it. Okay? You'll see questions like this on your next test. All right? Come on. Now, see, we've already solved this. Oh, no, we have not. Solve for A. A squared equals a negative 25. Present the solution set in words, in set notation, and graphically. A squared equals a negative 25. Is there any value that we can square that will give us a negative? There's not. Negative 5 we already know is a positive 25. There is no value. So to sit there and say present the solution set in words, okay, this might be actually be helpful to have this in pen. All right. The solution set for A squared equals a negative 25 is, you can either do the brackets or no solutions. Okay. Set notation. Okay. Remember what they said. You can use the brackets. Yeah, well, my brackets look messed up. Okay, let me try this one again. All right. Or you could sit there and write it as a null set. And then last but not least, graphically, okay, 0, negative 5, positive 5. There is no dot because there is no solution. Okay? That's what you're looking for. That is what you're trying to do when you're working on these types of problems. We're just trying to identify what solutions will fulfill the requirements for the equation. Okay? All right. I want you to do exercise 2 for homework, and I want you to do exercise 4 for homework. All right, example 4 for homework. All right. Okay. We will do exercise 3 for classwork. We will do exercise 4 for classwork, or example 5 for classwork. Okay. And we will do exercise 4 for classwork. All right, so exercise 5, identify the properties of arithmetic that justify why each of the following equations has a solution set of all real numbers. Okay. We will discuss this one again in class tomorrow as well. Let's go down here to look at exercise 6. Okay. Let's look at exercise 6. Create an expression for the right side of each equation such that the solution set for the equation will be all real numbers. All right. There is more than one possibility for each expression. I will give you the basics. If you can come up with another, I want to hear it. Okay? So, create an expression for the right side of each equation such that the solution set for the equation will be all real numbers. Okay? So in other words, we're looking at identity property. For all real numbers, we have to find expressions that are identical to the other side. Okay? They have to be identical. Okay? The idea is that these would equal each other. So like for example, 2x minus 5, I would do 2x minus 5. I'm looking at identity properties. Okay? It's no different if you look at you're looking in a mirror. Okay? The reflection you see in the mirror is identical to you. So you want to do the same thing for these problems. You're looking for identical. Okay? Like for example, x squared plus x. You can do two things. You could do x squared plus x, but I like the idea of doing x plus 1 times x. Okay? Those are equivalent expressions. And I'll be glad to explain to you why tomorrow if you want to know. Okay? 4 times x times y times z. I could even get really, really picky and say that's, okay, 4x cubed, y cubed, z cubed, divided by x squared, y squared, z squared. And I can tell you right now, you all are going to be like, Mr. Hale, what in God's green earth did you just do? Okay? I'll explain that to you tomorrow in class. Just be patient. Okay? Another one you could do is just simply 4zyx. Okay? It just needs to be identical in some form or fashion. X plus 2 squared. Okay? You could do x plus 2 times x plus 2. Well, if I could actually write x plus 2. All right. X plus 2 times x plus 2. Or you could do x squared plus 4x plus 4. Okay. Mr. Royal, what'd you do? I used the FOIL method we talked about yesterday to solve this expression. Or excuse me, today. X times x is x squared. 2 times x is 2x plus 2x, which would be 4x. 2 times 2 is 4. So x squared plus 4x plus 4 is equivalent to x plus 2 squared. All right? Like I said, if you have questions, ask me. All right. I believe, nope, we're not done yet. Okay. I want to cut it off right there. I will talk about inequalities tomorrow in class. I do not want to get into inequalities with you today. So we will discuss this in class tomorrow. So what I want you to do is, I want you to work on the problem sets tonight. I want you to do 9 through 18 as homework tonight. Okay? Work on those and we'll do the others together. All right? I want you guys to have a wonderful evening. I hope you guys understand this a little bit. If you don't, we will spend all day in class going through this together, okay? I promise you. I don't expect you to get it with a lesson. I expect you to get it when we talk about it as a class, as a group, but you got to watch the video. To make sure, if you watch the video tonight or in the morning, I don't care, make sure you comment below the video with your name and your favorite color. So like me, if I was to comment, I would put Walter Hale -blue because Mr. Hale's favorite color is blue. All right, you do that for me, and then we can, I can make sure you get proper grades for homework and for participation. All right, guys, y'all have yourselves a good night, and I will see you all tomorrow.